Okay, so this is the last topic that I want to cover with you. I try and get through all of it today if I can. And there's only slides really. There isn't an accompanying lab, although there's a GitHub repo that I'll make available to you if you're interested in looking at it. So you might remember on day one really when I was talking to you about this module, I said that there were links back to two modules that you did in third year. One was um, the cloud one. Was it called DevOps? I'm not sure what it was. I think it might have been called DevOps in third year. And the other one was the Web App Dev 2 module. So it's that second one that I'm kind of linking this lecture to. You might remember you were developing a React app and a Web API backend. So we've kind of dealt with the Web API side of it in terms of deploying Web APIs to AWS. It's the front end that I want to talk about today. And it doesn't matter whether it's a React or any other framework. The topic is kind of generic. It's not, or it's kind of it's framework agnostic, as they say. So this is roughly what I want to try and get through. It's quite a lot to get through actually, but we'll see how we get on. Just a quick bit of background to this idea of bundling. I'm pretty sure it was mentioned by the people that were teaching you the Web App Dev 2 module, but I'll just give you a quick recap on this notion of bundling a web app. Um, then we'll talk about, well, how do we deploy the front end or what servers or services can we use in AWS for deploying our front end application? And then we'll move on to this idea of having a full stack application and using the CDK to deploy both the front and back end um, in parallel. And also, once we have the front end and back end, is it possible to actually, the AWS will generate a um, a domain name for your front end, but it's kind of it's an AWS type domain name. We'd like to be able to associate a custom domain name with our web app if possible. So that's kind of what we want to try and get through. This is kind of a visual representation, and this is an image that I showed you way back. So we kind of know now how all this stuff here works, right? We've kind of covered all of that. Where's my mouse gone to? But yeah, we've covered all of that stuff. It's over here, and we can see now straight away that S3 plays an important role in uh, deploying our front end. Although there is another service as well called CloudFront, which we'll look at as well. Okay. So when we talk about the front end, we're talking about client-side rendering web apps as opposed to server-side rendering. And you might remember that um, when you are developing a React app, let's talk about React specifically. When you're developing a React app, there's this contrast between when you're working in development mode versus when you're working in production mode, or when the app is running in development mode versus production mode. Um, and when you're in development mode, there's this thing called hot module replacement, which is a really nice feature. And essentially, it means that you can make changes. As you make changes to your React code, you can get kind of instant visual feedback as to the effect of that code change. And that's a really nice aspect when we're developing a client-side web app. Obviously, we don't want that kind of hot module replacement or HMR. We don't want that feature when we've deployed our React app into a production environment because it impacts on performance and latency. Um, And another way of expressing this development versus production is talking about a dynamic versus a static version of your React app. If I switch over to VS Code, so I've got a simple, trivial React app project here. Okay, and this is using React and it's using the Vite uh, build tool, if you remember that from last year. And to we don't need to look at the code really. Sorry, I need to kill that there. Like if I go, if you remember npm run dev, hope that is the command. Um, what that does is it starts up a web server, a very standard web server, but the web server has been instrumented with various HMR related, hot module replacement related features. And I can now go to this URL and I can see my React app. Okay, that's my React app. There's little or nothing, there's little or no dynamics in it, but that's okay. It suffices. Although down here, what I will want to see down here ultimately when my React app is connected to a backend, I'd like to see this showing me the message from the backend just to prove that my React app is communicating successfully with the backend. But at the moment, this React app is just in standalone, working in standalone mode. But what I have here now is I'm in development mode right now, right? Which means I can go making changes to my React code, and when I save the changes, I can just flip over to the browser and I can see the effect of those changes, or get an error and fix the error, that kind of stuff. So that's kind of development mode. And also, we would say our React is we're working with a dynamic version of our React app. Now, when I want to deploy my React app into production, though, so I'm going to kill this session here. What I need to do is, first of all, I need to create a static version of my React app. And you might remember the way we did that when we were using Vite and React was we go npm run build, hit return. And what that does, as you remember, is it essentially kind of gobbles up all of your TypeScript code, uh, um, all of the code that I have here, and it transpiles it or converts it into JavaScript, and it puts all of that code into one file. And it essentially creates, in this case anyway, it creates this dist folder up here. And if I expand the dist folder, this is now my static version of my React app. There is an index.html page, and that HTML page, you might remember, is it's really a skeleton, and it has a reference to these two asset files here, which is a JavaScript asset file, and this JavaScript file that will contain all of my React code in JavaScript. Yeah, and the CSS one contains all of my CSS code, if I have any. So this is a static version. If I actually want to see what that static version looks like, I can do it locally. If I've got just an ordinary web server, Nginx or the Apache web server or any web server at all, and just point that web server at my dist folder, then I can see what my static version of my React app looks like. Now, there's a very simple web server that you can install. There are many of them. I've installed one called Serve. So if I start up my Serve web server and I point it at the dist folder, so I can now go to this, and surprise, surprise, I see the same thing. But this is a static version of my React app that I'm looking now. if I go making changes to my source code and save them, it's not going to be reflected here. So what we're doing, when I ran the npm run build there, we refer to that as bundling. We're creating a bundled version or a static version of my React app. Okay, that's background. And I'm assuming you know all of that from last year, and I've just recalled it for you. This is what I've done here. That's fine. Now it's that static version that is what we deploy. And if I just want to deploy it, if it's a React app that's not talking to any backend, the simplest way of deploying it onto the AWS platform is to um, upload it to an S3 bucket. And that's so what you're looking at here is just CDK code. So I'm creating an S3 bucket here. What am I doing? Okay, I'm making it public read because we need that to be able to access it. But the important property that I'm setting here, which you wouldn't normally for an S3 bucket, if you're just using an S3 bucket just for storing objects, um, then you would not set this property here. But when you do set this property, you're telling the S3 service that you are going to be using the contents of this S3 bucket essentially as a website. Okay, a static website. And all I'm really doing is telling it where is the index.html or the kind of home page for my website. So I'm telling it it's in a file called index.html, and it's actually in the base folder, if you like, of the S3 bucket. Okay, so that's that. And all I'm doing down here is this is CDK code, and what it does is it uploads the contents of some folder or folders from my laptop. It uploads it to this S3 bucket. Yeah. So, it's just a convenience, another CDK kind of convenience method that's available to me. The source is essentially pointing at the .dist folder, and the destination is my bucket that I've created up here. So that's all I need really. That's my CDK stack. If I do a CDK deploy of that, um, what the S3 service will do is it will generate a URL. So it might be something like this. Yikes. Might be something like this. And if I just uh, insert that URL into any web browser, then I'll get to see my website that's stored in my S3 bucket. Now I'm actually uploading the dist folder because the static version of my React app, that is essentially a website, right? Okay, it only has one HTML page, but technically it's a website. But we could use this exact same approach if I had a more traditional website with lots of HTML pages and CSS files, etc., etc. All I need to do it is just point it at the base folder of my static website, and this will take care of uploading everything into the bucket. And then I can just access my website using the actual URL or the domain name that has been generated by S3. Nothing really too exciting about all of that, but that's how you do it. Now, um, there is another service called the Amazon Cloud Front. And what it is it's a CDN, it's a content delivery network. What's a CDN? CDN is just essentially a network of servers that are globally distributed, and their main purpose is caching content. And the idea is, um, rather than when users around the globe are trying to access your website, rather than all of those requests hitting, in our case, the S3 bucket, which potentially could cause problems from a latency point of view. What the CloudFront service does is it will cache the contents of my website in these servers or nodes that are distributed around the globe. And these servers are going to be geographically closer to your users. Hence, the latency is reduced or the response time is increased. These network of caching servers, they're referred to as edge location servers. They're also referred to as points of presence or POPs. Okay, and all they do is they just cache any kind of web assets. That's HTML, CSS, JavaScript, images, documents, videos, whatever is part of your website. These figures are maybe about 2 years old, really. I don't know if they've changed since, but when I Googled it, this is what I found out in terms of CloudFront. Okay, it says 400 plus edge location servers or POPs, and they're distributed across 90 cities in whatever 47 different regions. Yeah. So, the visual here kind of shows that we've got a user in a particular part of the world. That user enters the URL of my website, or it actually won't be the S3 bucket URL. It'll be a CloudFront URL, but that's okay. We'll come on to that in a moment. That request will hit the geographically closest POP or edge location server to that user. And if it has the content that it's looking for, it'll serve it to them. If not, then the edge location server will go back to the original source, which might be my S3 bucket, grab it from the S3 bucket, it'll cache it locally, and then serve it to that user. Now, if another user in the same geographical area requests the same resource, it's now going to get it served from the cache in the edge location server. That's just that's how CDNs work. We know that. Okay, so CloudFront is a content delivery network, and we can configure that network for the purposes of our websites or our web apps, which means we can write CDK code, right, to do that. Now, in terms of cloud infrastructure, there are really only two resources that you create as part of your stack, right? There's something called the origin, which is essentially, for example, our S3 bucket. We've just got to tell it that a particular S3 bucket is going to be the origin for my CloudFront installation, let's say. That's quite a tangible thing. The second thing is a little bit more abstract. It's called a distribution. And this distribution resource, it kind of describes how we want CloudFront to essentially manage our website in terms of how the various edge location servers should do their caching, what kind of caching policy should they use, and some other stuff as well. So what we'll see is that in our CDK stack, we're going to have code that will essentially kind of create these two resources for us. This is a kind of, again, a visual, and I've kind of already explained now, right? So you've got your client, your end user, they send the request to access a particular resource, particular part of our website or the homepage, whatever. That request hits the edge location server geographically closest to them. First thing it will do is check in its cache. Does it have that asset that the user is looking for? If it does, it just serves it. If not, it goes back to the origin. So we now call this the origin in CloudFront terminology. And the origin actually, it can be an S3 bucket, but it actually could be any type of HTTP resource. Like it could be an API gateway, or it could be a load balancer. In our case, in this lecture, anyway, it will be an S3 bucket. Um, right, so there's nothing new really in that slide. So going back to the previous slide, you've got to tell, you've got to, in your CDK code, you've got to say, well, what is the origin for your particular installation? And the distribution, then we'll talk about, things like how should the caching be done here and some other stuff as well. A little bit more detail on origins. So as I've kind of already said, there the most common origin is an S3 bucket. Um, Now you want that bucket though, I suppose. You do not want that bucket to be open access. You don't want users to be able to get at the bucket directly. You'd like it to be more secure than that. Now, when NS3 bucket is linked to a CloudFront distribution, then you can create a special type of resource called an origin access control, which is a bit like a kind of a virtual IAM user. And you associate the origin access control with your with your origin, your S3 bucket, and you essentially kind of say that this origin access control entity has read access or read write access to the S3 bucket, and nobody else, no other type of resource can actually access the bucket. So you're just kind of locking it in really to be exclusively used by your CloudFront distribution. Um, CloudFront cannot be used. Yeah, you can actually use CloudFront as an ingress, where users can actually uh, upload images or upload videos or whatever. We won't look at that, but it certainly works for that as well. And that would be part of many websites, I guess. There isn't any caching. Obviously, if I go back to the previous slide, you're essentially saying you're allowing the client to upload. The upload will go via the edge location server. It won't be caching them though. The purpose of it will send it on then to the origin, and that will take care of it. So in case of an S3 bucket, it would just store it in the bucket. In the case of some other type of origin, then it passes through. If this is an API gateway, then it passes what you've uploaded back to the Lambda and it deals with it. Um, okay, so the origin can be an S3 bucket. Or it can be what I'm saying here, it can be any kind of custom origin, essentially any type of HTTP supporting resource. For example, as I've said, API gateway, application load balancer, an EC2 instance could be, or an S3 website. Uh, the reason I'm saying this down here, there's a slight difference between this using S3 here and using S3 here. When you're using S3 here, it's just an ordinary S3 bucket. You have not configured the bucket as a website. Whereas down here, I'm talking about where you have configured the S3 bucket as a website. In other words, if I go back a couple of slides, it's the difference between leaving this in or leaving it out. If you leave it out, then this is just an ordinary S3 bucket. And that's what I mean by here. Yeah. And in fact, that's how we are actually going to use it. We're not going to use S3 and configure it as a website. Um, website host. Uh, what do we get? Okay, well, the only difference in this image now is we have this origin access control kind of entity, which is kind of has exclusive access rights to this particular bucket. And this is kind of associated with the CloudFront distribution. Yeah. Other than that, this image isn't telling us anything new, really. Okay, let's look at actual code, whether that'll make it clearer or not. Okay, here's my CDK project. And if I go into the application kind of file, now it turns out there are two stacks being used here. But if you're thinking, okay, maybe one stack is front end and the other stack is back end, that's not how you interpret this. So I'm just going to ignore this stack here for the moment. That has a different role altogether, which we'll come to at the end of the lecture. This stack here, which I've called conveniently the full stack, this stack will be responsible for deploying both my front end and my back end. And for now, we don't care about this stuff down here. I'm just setting the region. I do have an environment file, uh, which is somewhere. It's not a .in file, but it's a kind of a TypeScript environment file. But you can see here the environment variables that I'm passing in. So I'm passing in region, which in my case will be US1. Account is just my AWS account number. We can ignore the other two environment variables for now. They're not relevant at this stage. So go back to my app file. So as we can ignore these for now. So this is just a simple stack uh, instantiation. So let's look at the stack file, which is this one here. It's not a lot of code in it. I do have some custom constructs as well, which you can see over here. And I'm using those custom constructs in this stack file here. And all I'm doing in this stack file is what am I doing? I'm simply creating an instance of my backend. Now my backend will just comprise of an API gateway with one Lambda. I didn't bother bringing in a database. We don't really need that. And the Lambda is just a simple Lambda that just returns a response like a hello world response. But that will suffice as my backend. So that's all I'm doing inside in this custom construct, just to show you the custom construct. But let's see, where is it? Here it is here. So this is all old hat to us now. Here's my Lambda function. Here's my REST API. And I've just got one endpoint, which is demo. Okay. And that's linked to the Lambda. And the Lambda, as I said, just kind of returns hello world, something like that. Okay, so back to my full stack file. Uh, I have a second custom construct, and this is the one that's kind of interesting today, really. So this construct, this is going to be responsible for creating my CloudFront distribution and my origin and all that stuff. Yeah. And I am passing into it the URL of my REST API because you can see um, where is it? Sorry. Here, this one here. I'm passing that into it. I'm passing some other uh, arguments into it as well, but again, we're going to ignore those for now. So let's look at this custom construct here. So it's called front end. Okay, so that's a hint, like it's going to create all the front end from my full stack app. And take it from the top, I have an S3 bucket. Now I've purposefully left these lines here, but I've commented them out. And the reason I've done that is to try and reinforce with you the fact that we are using this S3 bucket as an ordinary bucket. We are not configuring it as a website. And look, you can see I'm kind of locking it down. I'm not allowing any public access to this bucket. Later on in this stack file, I will have an origin access control entity that will have read access to the bucket, which it will need because otherwise my CloudFront distribution wouldn't be able to, retrieve files from the bucket. So it's an ordinary S3 bucket, and I've called it source it's the source. I could have maybe better name might have been origin, but source will mean it's the source. It contains the source assets for my front end web app. And here's where we create our CloudFront distribution. Now again, there are a number of kind of properties that I need to set, but most of them we are going to ignore for now. The only one we'll pay attention to is this one here. And really all I'm doing here is I'm kind of linking this distribution. I'm linking it with my S3 bucket. Yeah, because that's kind of what I'm doing here. Because the origin, as we know now, could be a number of things. It could be an S3 bucket, an API gateway, etc., etc. In this example, it's an S3 bucket. And also what's going on here is I'm creating my origin access identity, and I'm saying here that this code here will create the origin access identity, and I'm setting the permissions here as just being read. I'm giving the origin access, sorry, not origin access identity, the origin access control. I'm giving it read access to my bucket. Right. So that's what we mean by a distribution. Okay. Um, so it links, what is it doing? It's linking the distribution, which is kind of an abstract thing. It's linking it to my bucket, and it's also creating that special kind of entity, that special kind of an IAM entity called an origin access control, and giving it exclusive access rights to the bucket. In this case, it only needs read access though. Moving on. Okay, these are some more things that I'm setting. Obviously, I'm saying, look, the S3 should compress any assets before it sends them across the network to the edge location servers. I guess that's what that means. These are the only methods that I'm allowing clients to send requests to my distribution. So I'm only allowing get and head requests. And what's this one? Well, what all this is saying is if a HTTP request is directed at my CloudFront distribution, then just redirect it to HTTPS. Yeah. This code here, oh no, we ignore this code, not relevant now. We also ignore this code. And all I'm doing here is what we've seen already about uploading stuff to my S3 bucket. And again, I'm uploading the dist folder, which will contain my static version of my React app. I'm uploading something else as well, but I'm also going to ignore that for now. So we're ignoring a lot of stuff. I'm telling it where to upload it to, and I am linking it to my distribution. Sorry now. I'm linking it to my distribution, and I'm kind of telling it here where within the bucket it will find the base index.html, if you like, and it's going to be at the top in the kind of top folder of my bucket. This is kind of boilerplate, really. A lot of this stuff down here is boilerplate. All I'm outputting is I'm outputting the domain name that will be generated for my distribution, and that domain name then is I can use that in a browser uh, to access whatever is being hosted in my S3 bucket. So I've ran it. I've deployed this already, and when you deploy this stack, it does take quite a while for the deployment to complete, because essentially the bit that really is slow is the creating the distribution. Because essentially what AWS needs to do is it kind of needs to contact the various edge location servers around the globe and tell them about this new distribution that has just been created, so that the edge location servers will, kind of reserve an area in the cache for caching its content. Yeah. So I've already deployed it, and when I deployed it, the domain name that I got that was generated for me was this. Where is it? Oh yeah, sorry, it's down here. This here. The other one, this here, is just the domain name for the API gateway, which is my backend, but I'm not interested in that now. So if I grab this and paste it into a browser, okay, I get my React app, static version of my React app. So when I hit return on the URL address here, the request went from my browser to the geographically closest edge location server. It would not have any entry for this particular um, website. So the edge location server would have forwarded the request back to S3. S3 would have grabbed the index.html, because I didn't specify um, a specific resource. I just gave the generic domain name. S3 would have responded back to the edge location server. The edge location server would have cached it, and then it would have sent it on to my browser, and I've got it here. Yeah. If we just poke around a little bit at the AWS level, like if I go to the S3 service, now I gave my bucket a particular name, which is uh, this one here. Okay. The name is not relevant, right? But that is its name anyway. And if we look, we can see here, look, here's the index.html. Here's the assets file. You might remember, like when I was showing you the dist folder in VS Code, the index.html, the assets folder. Within the assets folder, there's a JavaScript and a CSS. And if I drill down into that, that's what I'm getting. So the S3 bucket has uh, does seem to have the content that I would expect it to have. Um, Other than that, we could go to CloudFront. And distributions, and there's my distribution. Okay, there's nothing I can really show you of interest right now anyway in this part of uh, the lecture. Uh, Although like Origin presumably will point it at my S3 bucket somehow, and behavior. Behavior was one of the things that I configured. If we go back to the CDK code, signing up, default behavior was something that I configured. All right, so there's something there anyway in CloudFront. Back to okay, so what's next? Yeah, so CloudFront's those POP servers or edge location servers, their main role is caching. And we know what a cache is. It's a high performance key value store. The CloudFront cache, we say, lives at okay, that's all right, edge location server, we know that. CloudFront identifies each object in the cache. Well, you know how caches work, right? The keys uniquely have to be unique, and they identify a particular asset from your website, be that a HTML page or an image or a CSS file or a JavaScript file. Um, let's see. Sorry, where identifies each object in the cache using the cache key. Well, that's okay. Um, obviously we want to maximize the amount of cache hits. That's all right as well to reduce latency. That's fine. When you make changes to if you make changes to your React app and you upload the changes to your S3 bucket, your edge location servers now are potentially out of date. Now, if you do a CDK deploy having made changes, then what CloudFront will do is what we say is it will invalidate each edge location server's cache. It'll essentially send a request to each edge location server telling it to flush the particular part of its cache store that relates to our particular distribution. That happens automatically. But sometimes when you're testing, when you're kind of in test mode and maybe you're making changes to your React app, and rather than doing a full deploy, you might actually kind of manually upload uh, your updated React app to your S3 bucket. But then you have to kind of manually perform this invalidation, and CloudFront actually makes that easy for you. So if I go back to, that's something I can show you in the distribution part. So if we go back to here and we'll go into our distribution, and you can see over here there's invalidations. Now, I just did one CDK deploy, so there was only one invalidation. But if I had done a number of CDK deploys, whether I would made changes to the front end or the back end, um, each deployment would add a new invalidation entry here. In other words, it would trigger a flushing of the caches in each of my edge location servers. But you can actually do that manually. So if I create invalidation here, and what you can do here is you can kind of tell it which part of the cache you want it to flush. And you do that by specifying some sort of key. Remember, our cache is a set of key value stores, and maybe the keys follow particular patterns. So you can specify the pattern of the keys within the cache that you want to have flushed. If you want to flush everything, then what you can simply do is go slash star. Okay, and so if I trigger that invalidation, what's happening behind the scenes now is, as I said, CloudFront is sending out a request to each of its edge location servers and telling it to flush the particular part of the cache if it has a cache relating to my distribution. Uh, Now, I can prove to you that that invalidation has actually worked. The way I can do that is if I now try and request, uh, so if I open up my developer tools here, and if I go into the networks tab, networks over here, and if I do a manual refresh here, uh, hopefully that has done a refresh. And if I check the, if I check, so these are the files. It obviously pulled down the index.html, but the index.html contained references to my JavaScript file and my CSS file, these two here, right? So there was a number of actual interactions between my browser and the edge location server. But if I just select any one of these, right? Let's say take this one, and there is a response header, which is this one here. And this is telling us that when I did the refresh, uh, what happened behind the scenes, but the education cache generated a cache miss. And that would make sense because I invalidated I triggered a an invalidation, which flushed out my cache. And so when I requested the resources again, or requested the assets again in my browser, the education server didn't have any record of them. So it had a cache miss and it went back to the origin to get them. Now, if I do a couple of refreshes here in my browser, essentially kind of forcing the edge location server to cache the resources. Probably does it after the second one, but to be sure. Now, if I select the same resource or the same asset, whatever you want to call it, and look at the response, the cache response header, uh, I'm still getting a miss. I shouldn't be getting that. Let's do a few more. That should not be now. It should be giving me a hit. Why is that happening? I wonder. Did my that seem to work? And okay. Don't know why that it should be giving me a cache miss. The only thing I don't like is I'm not getting a flashing there when I try to do the refresh. It's obviously not going to behave from me, but let's just pick a different resource to see if that makes it any better for me. Yeah, I don't know why that's happening now. It should be hitting the cache at some stage. I'm not going to dwell on it though. It doesn't make sense now. Yeah, okay, I'm gonna move on. It should really show after a couple of refreshes, it should show a cache hit rather than a cache miss. I don't know why that's not happening this time though. Okay, let's push on. Cache invalidation, that's all right. I talked about that. Well, the screenshots show you what I did expect to happen, which is, okay, I'm showing you here. Look, there was a cache miss. And then after a couple of refreshes, I was getting a cache hit. What am I doing? I'm getting a hit there, sorry, getting a cache hit there. And then I did an invalidation, I think, and when I refreshed the page, I was getting a cache miss. So the screenshot is telling me what I wanted to happen, but there you go. Let's move on. The cache keys, you have control over what the structure of the cache keys are, and that's part of the configuration of the CloudFront distribution in your CDK code. Now, the default key for a cache entry, it essentially takes the host name, of um, your website plus whatever particular asset you're trying to access. So, for example, if this was the domain name of your website, then, and this was the particular path to the asset that you were trying to access, one of our edge location servers kind of received that request and went back to the origin and got the actual resource, when it stores a cache entry for that resource, then this is actually going to be the key of that cache entry, which is what I'm showing you here, right? And the value would be the actual HTML page itself, obviously. So that's the kind of default cache key structure. But you can control that though. You can configure it, and you configure it by what are called caching policies. There are two caching policies that you have control over. One is called just the cache policy. That's the one that controls the cache key. There's also a policy called the origin request policy. I'll come on to that in a second. In terms of the cache policy, uh, you can do things like maybe you want to include HTTP header key value pairs as part of the cache key itself. So you can say, look, I don't want any HTTP headers to be involved in the construction of the cache key. Or you can provide a whitelist of HTTP headers. And the actual headers themselves, they're kind of key values because HTTP headers are also key value pairs. The actual key value pairs are kind of concatenated and they are added on to what I showed you on the previous screen. They're added on to this to form the full cache key value. Because I say that somewhere? Sorry, if I go back, sorry, I'm jumping around a little bit. Like I'm saying here that it may be the case for your particular website stroke web app that uh, the person that's making the request may actually influence the content that they receive back, or the device that they're using may influence the content that they get back. The kind of form factor, or these other uh, characteristics of a request from a browser. They may all have control over the actual content that they receive back, which means that there's going to be different cache, edge location cache entries for the different kind of characteristics that you're specifying here. Yeah, and so that's why we might have the option of actually including HTTP headers to form part of the cache key. But anyway, you can have none, a whitelist. Cookies may also control the content that is returned back to the client. Again, you can set the cookies to be none. You don't want the cookies to be involved at all. You can specify a whitelist of cookies. You can say something like include all cookies except certain ones, or include all cookies. So there's lots of options available to you. Query strings can be included as well as part of the cache key uh, construction. Control. You can also control the TTL uh, of your cache entries. So that's policies relating to the construction of the cache keys themselves in your edge location servers. The second policy, the origin request policy, what that controls is, you see, when a request goes from a browser to an edge location server, if the edge location server gets a cache miss, then it's going to send the request on to the backend, to your origin. But what this policy controls is, well, how much of the original request from the client, how much of that should be included in the request that's forwarded on to the origin? Should all of the headers be included, for example? Should all of the cookies be included, etc., etc.? So this policy controls the request that's sent from the edge location server back to the origin. And again, you can control how much should be included. HTTP headers, which ones, none of them, all of them, a certain subset of them, which cookies, which query string parameters. Sorry. Uh, and this kind of visual shows you uh, the difference between these two policies. The cache The cache policy controls the construction of your cache keys. The origin request policy that controls the kind of communication between your edge location server and your backend. And these are all configured as part of your distribution configuration in your CDK code. Now, conveniently, we're ignoring all of that, but that's the kind of stuff that you would be configuring. Now, so far, all we've been doing is kind of focusing in on the front end, but the front end is presumably going to be talking to a back end. And um, how does the front end discover the the URL of the back end in order to allow it to communicate with it? Because the back end is going to be deployed as part of our CDK deployment. And, we know if it's an API gateway, the API gateway gets its own URL. how do we kind of pass that URL or make it available to the front end? Okay. We could do it manually, like we could hard code it into our React code. That obviously is not desirable. Or we should try and automate it some way. So I'm just going to give you one approach towards the automation of the kind of integration between the two. Is that what I want to do next? Yeah. Let's go back to our CDK code and let's go into the front end construct. Well, sorry, let's go to the full stack. Now, I've already mentioned to you, right, that, okay, here we're creating via our custom construct, we're creating our backend, our API gateway, and all that's behind it. Here we're creating an instance of our front end. And as I've already said to you, we are passing in the URL of our API gateway into our front end construct. Okay, so let's go back to our front end construct. And so we've seen some of this already. I have skipped over bits of it though. Now I'm going to go back to it though and see this here. All I'm doing here is just creating a local variable called config. And it's just an object. This is just plain old JavaScript stroke TypeScript. This object has a key called that, and the value is essentially the URL of my API gateway. That's fine. Now I'm actually taking that construct and here I'm actually uploading it into the S3 bucket. So you can upload anything you want to into the S3 bucket. This is uploading the contents of my React app, my dist folder. Here, I'm actually uploading the object that I've just created up here. And that object will contain the backends, the API gateway's URL. And if I go back to S3, here's my bucket, and here's config.json. Yeah, and if I click on it and open it up, yeah, here's my object, the key, and so this is the actual URL of my API gateway. Okay, that's fine. That doesn't really answer the question that we want answered though, is how do we make this now kind of available to my React app code? Uh, is that what I want to do next? Let's see. Yeah, so let's go back to my React app. Let's see. Here's my React app. I just want to undo something here first. And if I go into my React code, okay, so it's a while since you looked at React code, but you might remember this use effect and use state hook. I have a use effect hook here, and I'm calling a local function called get demo endpoint, and that function is defined inside in this file. Let's see. Um, there's the function there, and it's making a fetch call. Now it's importing a variable here from another file called uh, config, and that file is just a local file, which is this one. And it's making a fetch call, and it's looking for config.json, and it's a relative path name. Now, what that relative path name is, it's relative to where it's really relative to my S3 bucket. It's a path name within my S3 bucket. Um, when we did the npm run build, that created it took all of my TypeScript code, converted it into JavaScript, bundled it all into one JavaScript file. Now that JavaScript file, was loaded into my browser and executed and all of that. And this here that we're looking for, it's a path name relative to where that JavaScript file came from. And we know that came from our bucket. So effectively what's happening here is I'm fetching the config.json file that I just showed you in the up in my S3 bucket. I'm just fetching that file. And we know that that file contains the URL of my API gateway. And all I'm doing here is I'm just creating a local uh, object, right? And I'm storing the API URL within this object. The reason it's a little bit more elaborate is, we could have a number of API gateways as our backend. For example, we could have an API gateway that's taking care of all of the authentication stuff, which is what we did in the labs. So you would do a similar kind of thing. The config.json in the S3 bucket could contain the URLs of all of the API gateways that make up your backend. And so you would just kind of configure this large object here to contain all of those URLs. Right now, we're only interested in this one here. And back to here. So this object now is a reference to that object that I showed you in the previous file. And I'm just digging down into it. And essentially all I'm doing here is I'm making a fetch call to my API gateway. And I'm specifically trying to access the demo endpoint within my API gateway. The demo endpoint will, in API gateway, it will map that endpoint to my Lambda function. And whatever the Lambda function returns back, that's what I get kind of back here. And that's what I eventually hand back to. That's eventually what I get in the response object, here. So overall, kind of, I've just in my as part of my deployment of my stack, I've just created a JSON file, put it into the bucket. In that file, I can put anything I want to into that file. What I've put in is the URL of your API gateway. And in my React code, I am looking for that JSON file in the bucket. And I know the structure of the JSON object within the JSON file. And I'm pulling out the API gateway's URL. And I'm using that I'm making a fetch call to that then in my React code. Again, if I go back to here, it's trying to access the demo endpoint part of my REST API. And if I switch back to my CDK, and if I go into this custom construct here, which creates the API gateway and all the rest, I showed you that earlier on, but just go back to it. Uh, Here I'm creating my REST API, and here I'm creating my demo endpoint, and I'm linking it to my single Lambda function. Here's my Lambda function. Forget about all that stuff. Here's the Lambda function. And, all it does is it returns the response message, success in connecting to API. Uh, and that string is, that string is what you're seeing here. So uh, I have successfully invoked my backend from my React app. Uh, Hence, they are integrated at at runtime. Now, the way I've done it, creating that config.json and putting that into the S3 bucket, that's just one way of doing it. There are other patterns that you could use, but certainly that one is successful. Right. Back to my slides. Sorry, just for a second. If I go back to my React app, jumping around a lot, I know, but I'm going to app.js, app.tsx, sorry. This is where I'm actually displaying the message. And that's what you saw in the browser. Backend API message and whatever was returned by in my case, the Lambda. And that's what you saw here. Yeah. Okay. What's next? The next thing is, you know, uh, I'm using the domain name that was generated by CloudFront for me. Again, if I go back to the browser, it's something, it's a kind of a randomly generated name, .cloudfront.net. So that's kind of telling me, look, it's actually a CloudFront generated as opposed to an S3 generated uh, domain name. And that's fine, but it's certainly not very kind of user friendly, let's say. It would be nice if we had our own custom domain. And I have a custom domain because if I go my app .diarmuid.com, then I'm actually getting the same, I'm accessing the same web app, full stack web app. Yeah. So how did I link my custom domain to my kind of CloudFront distribution? That's it. That's going to be the final piece of the jigsaw. Yeah, so we want to associate a custom domain name with a CloudFront distribution web or CloudFront enabled web app. So what you've got to do first of all is you've actually got to buy buy your own domain name. So some of you may have already done that. There are lots of places you can buy a domain name from. I bought my domain name from AWS themselves, but you could buy it from GoDaddy is another website that sells domain names. This oddly named porkbun.com. You could go there and just buy your own domain name if it's available. And they're quite cheap. If you haven't done it already, they're actually quite cheap. I don't know, maybe 10 euros um, would be the cost. Now that's a recurring cost every year, €10 every year, but you can, if you want to drop, if you want to hand the name back, so to speak, then you're no longer charged. So they're certainly not expensive things to buy. So that's step one. You just buy your domain name and go to whatever website you want to buy it off of. Step two, so you've got to, in the AWS Route 53 service, which is essentially a domain name service that AWS provides, and you probably would have used this last year, I'd say. What you've got to do is create what's called a hosted zone for your domain name. How do you do that? That's pretty simple. It's actually something that you've got to do manually. You can't do that within the CDK stack. So if I go back to here and if I go to the Route 53 service this time round, click on hosted zones and just, create your hosted zone. And the creation, all you will be asked is, what is your custom domain name? So my name that I bought was dermotoconnor.com, and hit create. And here's my custom domain. Here's my hosted zone, sorry. Here's my hosted zone for my domain. If I go into it, and if I just expand here, each hosted zone is given an ID. Now that ID is going to be relevant in a few moments because I need to put that into my CDK stack. Now it also creates some what are called records associated with your hosted zone, which is kind of what you're seeing down here. I'm not going to go into explaining these now. That's kind of outside the scope of what I want to cover with you. So I've created my hosted zone for my custom domain. So that's step two ticked off. Oh yeah, when you create a hosted zone, what in Route 50, sorry, yeah, in Route 53, what Route 50 and Route 53 is essentially, despite its name now, it's not a router, it's really a domain name server. Um, what it does is, and again, it has a network of AWS has a global network of DNS servers. And when you create a hosted zone, what Route 53 will do is it will inform a subset of its network of DNS servers about your domain name. It essentially kind of links your custom domain name with an IP backend address, right? Uh, and so, sorry, if I go back to my hosted zone, you can see here, right? These are the actual DNS servers, which is a subset of all of the DNS servers that AWS Route 53 manage. These servers now have been informed about my custom domain name. Uh, Now, if you bought your custom domain name off another domain name registry, um, then you've essentially got to tell that domain name registry about this list of name servers. And it depends on the uh, domain name registry that you bought your custom domain name from as to how you do that. But it's usually a very straightforward step. So you simply just grab these list of name servers and you paste them into a particular kind of simple web form that the domain name registry that you bought your custom domain name off of, you paste them into it. And you're essentially telling that domain name registry, look, these are the servers that contain details about my custom domain. So if a user in a browser anywhere in the world types in your custom domain name into their web browser, we know how DNS works. Your web browser is going to contact its nearest domain name server and ask it, do you know anything about dermotoconnor.com? Do you have an entry for dermotoconnor.com? If it doesn't, then it will send the request on to another domain name server. Eventually, that request will hit one of these domain name servers, and they will have an entry for dermotoconnor.com. Okay, that's step 3 that we're on to. So step 1, 2, and 3 are all manual. Now, okay, we've got our custom domain name, but also we will want to communicate over HTTPS using that custom domain name, which means we need to generate a certificate associated with our custom domain name. And in the AWS world, because there is a service called the Certificate Manager, and you can use this service to create a certificate for you. Now, you may actually want to create your certificate some other way, and you can do that. But then what you would have to do is upload your certificate to the certificate manager. What I'm going to do is I'm going to get the certificate manager service to generate a certificate for me. Now, this service, okay, it's available in all regions, but if it's only the US East 1 region that has the functionality for creating certificates for you, which is what I'm saying somewhere here. Yeah, the US East 1 region. Now, in order to automate the creation of my certificate as part of my CDK code, I am going to use a separate stack to do that because I have to use a different region from EU West 1. I cannot put the CDK code for creating my certificate in my EU West 1 stack. I have to have a separate stack to do that. And back to here. That's what this stack is all about. Okay. So it's just another stack. It's just another CDK stack. But I am telling it, look, this stack is targeting the EU West 1, sorry, US East 1 region. Now, you might remember way back in week 1 or 2, you bootstrapped um, the EU West 1 region to allow you to use the CDK framework. You would actually have to do the same with the US East 1 region. You'd have to bootstrap that region, your account in that region, to be able to use any CDK code. So let's assume we've done that. And let's look at this stack. There's not a whole lot in it. The first thing I'm doing is I'm grabbing my hosted zone. I'm kind of doing a lookup of my hosted zone. By the way, as you may know, the Route 53 service, it's not region specific, it's a global service. Okay, so that's just by the way. So I'm essentially here doing a lookup of my hosted zone, and the way I'm telling it what hosted zone it should try and grab, I'm telling it to look up a hosted zone associated with a particular domain name attached to it and a particular hosted zone ID attached to it. Now, these two values here are being pulled from my environment file. If I go back to that, yeah, so domain is dermotoconnor.com or whatever your custom domain name is. The hosted zone ID, you grab that from the Route 53 service. I showed you there when I clicked into the hosted zone that I created. The zone was given a generated ID, and you have to put that ID in here. So that's picked up by my stack. So now my stack has a reference to my hosted zone in Route 53. And what am I doing next? I'm just, look, this is how you get this is how you get the AWS Certificate Manager service. That's what I'm talking to here. That's the service that I'm talking to here. This is how you get it to generate a certificate for your particular domain name. Um, Now I'm actually asking it not to generate a certificate for my domain name, but for a subdomain within that domain name. And the subdomain that I've just arbitrarily picked is the MyApp subdomain. So myapp.dermotoconnor.com. I want a certificate, a certificate generated for that subdomain. And I'm just using the AWS Certificate Manager service to do that for me. That's the effect of that there. And I'm just making that certificate. I'm making that certificate available. Well, I know that's just the the policy, the kind of destroy policy. All I'm doing here is I'm just making that certificate available to other stacks within my application because I actually need to pass that certificate now into the other stack that I have, the full stack. Uh, if I go to the certificate manager service, now I need to switch over though to see here it's currently in the EUS1 region. And this the certificate manager service is available in every region, but as I've already said, for generating certificates, although we can see my certificate here because it's associated with my account, but um, yeah, so that's okay. Look, that is the certificate that it generated for me. I didn't think I could see that from here though. Okay, there it is anyway. So that's the end of that stack. And as I said, I'm exporting, if you like, the certificate from this stack. And the reason I'm doing that is because I want to pass the certificate into my full stack. This other property here, because I've got two stacks that are operating in different regions, then you need to essentially enable this property here, this cross-region property, for this entire application to work. Okay. Now that means now we can go back now into this stack again with this certificate available to us. And where do we use that? And we can go straight to the front end custom construct. And it's actually used in the distribution. So here we are configuring the certificate part of our distribution. We're essentially telling CloudFront that any HTTPS requests, you should use this particular certificate for the encryption, decryption, okay, between client and server. And I'm not sure if that's it actually. Is it used anywhere else? Oh, sorry, no, there's a bit more. I also need to, in Route 53, I need to create some Route 53 records for my particular subdomain. When I created my hosted zone, first of all, there was an entry, there was a kind of a record added to that hosted zone for dermotoconnor.com. Let me show you that. Like essentially, let's go down into it. Essentially, what I want to do is I want to create, see this record here, my app, well, it'll be myapp.dermotoconnor.com. That's the subdomain that I have registered the certificate against. And I need to create a record in a Route 53 record for that subdomain. Otherwise, when somebody across the globe types in myapp.dermotoconnor.com and that request travels to the various domain name servers, I want that to eventually map back to my React app in my CloudFront distribution. And really, this record needs to be in the hosted zone for my custom domain for that to happen. Okay, that's as much of an explanation as I can give you about this record here. So how do I add that record to this list of records for my hosted zone? That's what this code here this code here is doing. And that's all. I think it's there's nothing else that I need to do. There's no reference to the certificate there, I think. No, that's it. So add a certificate to the CloudFront distribution. And number two, create a record in your hosted zone for your subdomain. And when you now do CDK deploy, then, and it does take a little while for that to kick in really. But when it has fully, by kick in, I mean um, the name servers, the domain name servers that have been registered against your custom domain, they have to kind of be informed of this subdomain as well that links back to your CloudFront distribution. And that can take a period of minutes, if not longer, to take effect. But once it has taken effect, then that allows you to type in myapp.dermotoconnor.com from any browser, and you get served up your React app, and it's connecting to your API gateway, etc., etc. Yeah, so there's a lot of stuff going on there, I appreciate. And I can tell you now, I didn't want to tell you this at the beginning of the lecture. I can tell you now that none of this stuff is going to be in the exam. Okay, I'm just kind of covering this stuff to try and kind of tie a nice bow around everything that we've done and link it back to the kind of web app dev 2 stuff that you did in third year. What I will do though is I will make all of this CDK code available to you in a GitHub repo should you want to actually look at it or potentially maybe even reuse for your own purposes or play around with it. Back to my slides. So we've done that. Attach the certificate to your CloudFront distribution. We've done that. This is the record that you need to, they're called A records. And I haven't explained the Route 53 stuff, admittedly, but I'm assuming that the DevOps module that you did in third year would have dug into Route 53 a little bit because that module was more focused on the whole kind of networking side of things. Um, so anyway, that's what the Route 53 code in my CDK stack was doing. It was adding this A record to essentially link your subdomain or my subdomain with my CloudFront distribution. And that's it. I doubt if there are any questions, but I'll pause in case there are. Now, next week, there won't be any lecture next week. There actually won't be any labs next week. I will be available on Slack, so I probably won't turn up to the labs next week unless somebody wants to meet me face to face, and that's fine. I can certainly turn up for that. There won't be a lecture. I will uh, post a message on Slack giving you some more details on the exam, though. And I'll try and get that done as early as I can next week. As I mentioned yesterday on Slack, the exam is scheduled for Thursday, the 11th, which is the Thursday of week 13. So not next week, the following week. Um, and so, there's no point in me giving you any detail on the exam now, because I don't have it, but you probably wouldn't get into preparing for it until well into next week anyway, if not even the beginning of week 13. But I will give you some heads up on the kind of structure of the exam and how best to prepare for it. It is an open book exam. Open book means you can access any of the labs that you've worked on during this semester, any of the notes, any Stack Overflow if you need it. It's unlikely that you will need it. My advice would be to go back to um, the messaging lab and and make sure you really understand all of the features that we've looked at in this lab. Like any of these labs, you could just go cutting and pasting it and it all works for you, but you need to reflect on it too. Okay, I've nothing else to say to you. Are there any questions?
Yeah, hello.
Hi.
Hi. So, we were just saying from the results yesterday that some like we were talking, I was talking to some other students and that the um the grading seems a bit ambiguous and like there were some guys who were like maybe the grading seems like quite not random, but like we would like some more kind of definition on how the grades have been given and how the breakdown kind of works.
Okay, let's go back to. So I have a spreadsheet. I can't show the spreadsheet now because there's names in it, but I can anonymize it. So what the spreadsheet would show is it would have columns. Sorry, now let me get the grading spectrum. Sorry. Just let me, I'm going to stop sharing for 1 second, okay? Okay. Can you see my screen now?
No.
Okay. So you can see that spreadsheet now. So what I did was these are the different, this is the kind of the breakdown, the detailed breakdown uh, that I've used. So each column, this column here is worth 30. So what I was looking for there is just your REST API and just the basic lambdas. You know, that was all, if that was all intact, then you got 30. This column here, DB, that was mainly about the database seeding. So I just make sure that that was, you were doing some seeding, you got 10 marks for that. The labels here now mean nothing to you, but they mean something to me. This column here was where I was checking to make sure that you were, when you were sending requests, you were just using IDs, but then you were converting those IDs into uh, keys, like, you know, prefixing them with W or A or M and all that kind of stuff. That you were doing that in the lambdas, and you got 10 marks if you were doing that. And essentially this kind of this here now, so it's 30 and 40, 50. That's roughly linked to, well, it's not roughly, it is linked to the good grade band. That's what I was looking for. Okay, then we move on to the very good, which is here in my spreadsheet. So I focused in on the get awards lambda because there were lots of different options there, and I was seeing, you know, not necessarily that you were covering every single one of them, but you were certainly covering a good spread of the different options in the get awards. And so you got an extra 5 marks for that. This was whether you had Cognito plugged into it and working. 3 marks for that. Only 3 marks because we had done all of that in the labs really. This was if you had the API key working, 7 marks for that. So that kind of covered the very good grade band. These two columns here are linked to I think I call it the excellent grade band. Okay. This one here. And for that, I was looking to see, were you doing the user logging uh, correctly? You got 6 marks for that. This was the database state logging, 9 marks for that. 9 because you really had to look up that kind of stuff yourself. And we're left then with the remaining grade band, which was the either multi-stack or Lambda layers. Only a small number did Lambda layers. A number of people did multi-stack, but they just had two stacks that weren't integrated. So you only got maybe 2 or 3 marks for that, really. They had to be integrated. There wasn't a whole lot to making them. By integrated, I mean you're kind of passing values from one stack into another stack. Typically, people might have had the Cognito stack and a stack for the app itself. But you would have to pass the Cognito's kind of user pool and ID and the pool client. You'd have to pass that from the Cognito stack into the other stack, and people weren't doing that. Some people weren't, some people were. So that was kind of the detailed breakdown, right? Now, what I gave you in the breakdown was kind of a summary of that. So I took this column and this one and brought those together. And that was the first part of the breakdown, the REST API and Lambdas. The second part of the API, I think, was authentication, which is obviously these two here. These two and this one, I brought those kind of together because that was kind of linked to the authentication as well. The third part of the breakdown was the database. I think I just called it database and state change. So I took this column, which is the database seeding, and this column and brought those together. And the final part of the breakdown that I gave you was what I called independent learning, which is this column here really on its own. So that's the explanation. And I know you didn't mean it, but it was far from random. So that's the detailed breakdown marking scheme that I used. And I gave you a kind of a summary of the breakdown because I just wouldn't have time to go entering all of these values in the feedback that I gave you. I'd be there for the whole 2 days trying to type them all in. I don't know. How do you feel about that, or anybody else really?
My only kind of I wouldn't say gripe, but like I got put into the good grading spectrum when the functionality and stuff that I had implemented, like the security and functionality, like I hit all the HTTP requests. I had the post delete requests, and I had the extra security for the get requests and stuff. And so I would have thought that would have gotten me into the very good grading spectrum, but I was put onto like the low end of the good spectrum, and I kind of just that's why what I was wondering.
You'd have to come and talk to me really in
Yeah,
separately.
yeah.
It may be I don't know. I'd have to look at your detail. Just because you had Cognito, like Cognito didn't get you an awful lot, just got you 3, so you might have lost marks. Like I'm just you might have lost marks and marks here. It's not so much that people fit into a band. Okay, the mark might suggest, oh, I fit into a particular band, but people might have. I go back to here. People might have, let's say they had the user activity logging implemented and it was working. So they're thinking, okay, well, I should have got 70 plus then. but you might have actually lost marks in this stuff, as you know. That's why it would bring you back from from excellent to very good,
Yeah.
you know. Uh,
Okay.
but you're free to. Did I say that in the? Maybe I didn't say it in the Slack message. If you want to come and talk to me, people can do that. I can turn up at the labs next week. Maybe on Monday. I'll turn up at the Monday lab. So if anybody wants to uh, get a detailed breakdown, I'm happy to do that.
Thank you very much.
Anybody else? No. Okay. We'll leave it at that for now. Thanks.